And I can't tell you how many parents I've seen breathe this big sigh of relief when they realize that while they need to help their child pay for their undergraduate education, they're not going to be stuck with also supporting them through 4, 5, 6 years of graduate school, because what happens is in the first of all, the graduate school will waive your tuition. You don't pay anything to go there. And second of all, in the first year, you're typically paid to be a teaching assistant. And then after that, you're paid to be a research assistant, typically out of a grant that the faculty member who is supervising your dissertation research will have money that they can use to pay you a salary. Now, you're not going to get rich on this, but for a single person, a single young person, it's definitely enough to live on. So that's some good news if you weren't aware of it already. It's a long road to get to the point of being a faculty member at a research institution. A PhD is not enough. You have to do several what we call postdocs, postdoctoral research experiences afterwards to gain independent research experience and establish a publication track record before schools will consider you for hiring, because they emphasize research and publication in their faculty members. And so you need to have established that you're capable of producing high quality research independently. Typical postdoc is 2 years, some of them are 3 years, and you need to do at least 2 or 3 of them in order to start being competitive to get a faculty job somewhere. Again, with some real world examples, this is Rachel Rotenbacher from the class of 2008 here at OWU. Rachel and I still work together. We still collaborate because she did star spot research with me and decided she liked it enough to keep doing it. She went to the University of Michigan and got her PhD back in 2015. Then she did a postdoc at Stockholm University, and today she's in her second postdoc at Yale. And so she's on the track where she's hoping to reach the point where she can become a faculty member doing research at a PhD granting institution. Another real world example is Tony Wong from the class of 2010. He majored in mathematics and astrophysics, and then he went to graduate school in applied math at the University of Colorado at Boulder. And today he recently started as an assistant professor at the Rochester Institute of Technology in the School of Mathematical Sciences. So he's a math professor, but he's studying climate change. And climate change is applied physics. So his physics background was crucial to getting him where he is today, even though, strictly speaking, he's a math professor. He uses the tools of physics, the physics knowledge that he learned by being an astrophysics major in order to study climate change. Now, another route that one might take for a career path with a physics and astrophysics major is to become a faculty member at a liberal arts institution. We have those here in the United States. That also requires a PhD. Postdoc experience is advantageous, but not always required to get a job at a small liberal arts college. A difference is that there's much more emphasis on teaching at the small schools. So if your passion is teaching, and I discovered when I was in graduate school how much I love teaching, if you have a passion for teaching, then this could be a good route for you. It was a better route for me than being a researcher at a large institution, because research is important to me, but so is teaching. And so I wanted a situation where I would do a lot of teaching. At a big school, you might teach one course per semester or one course per year. At a small school, you teach multiple courses every semester. That's just the way I want it. It's expected and rewarded at a small school. What's also expected is that you will involve undergraduates in your research program, because at small schools without graduate programs, it's all about the undergraduates. And so you need to be able to have a program of research that can get them involved. In fact, if I can put in a pitch for small schools here, if you are at a small school without graduate students, then by definition, you're the kind of student that that school is about. The large schools with graduate programs, the faculty there tend to be most interested in educating their graduate students because it's the graduate students who help them can carry out their research and publish papers and so forth. And that's how they're evaluated. At small schools, where teaching is more important and we really value mentoring undergraduates, you are by definition the kind of student that faculty concentrate on here. We're all about you. So if you go to a small school as an undergraduate, and then if you're interested in grad school, you go to a large PhD granting institution where you're a graduate student, you'll again be the kind of student that the school's all about. So you get the best of both worlds. If you go to a small school, you're the kind of student at that time that the school is all about. Then you go to a graduate school, and again, you're the kind of student that that school is all about. So win-win in that situation. Just for fun, here's a real world example of somebody who went the route of becoming a professor at a liberal arts school involving undergraduate students in his research program. Namely, there I am in the middle on the observing deck at Perkins Observatory, where I have a computer-controlled telescope that I was involving those two fine undergraduate students in my research with. Okay. Now, I really want to emphasize that most PhD physicists and astrophysicists do not become professors. If your dream is to be a professor someday, go and try to realize your dream, but I urge you not to define your success in terms of whether or not you end up being a professor someday, because many more PhDs are produced every year in physics and astrophysics than new faculty job openings become available. In the US, it's about 1,800 PhDs produced every year, and about 350 faculty jobs on average become available every year. So there aren't enough faculty jobs to go around. But I need to emphasize that a career in the private sector can be just as fulfilling intellectually. You can have a really fulfilling, intellectually stimulating career in the private sector. And beyond that, it usually pays better as well, which is nothing to sneeze at. So to show you what I mean by that, here is a graphic from the American Institute of Physics from a couple of years ago. Starting salaries for physics PhDs, excuse me, in the classes of 2013 and 2014 combined, for potentially permanent positions hired into jobs which are intended to become permanent. So notice at the top there, for the private sector range, we're talking starting salaries from about $80,000 to almost $110,000 per year. At university and four-year colleges, the range was more like $50,000 to almost $70,000 per year. So you're making a lot more money if you go into the private sector. So nothing wrong with that, right? So that is something to have as a consideration. Again, as a real world example, one of our students would be Taimur Islam. He majored in physics, graduated back in 2013. He and I are still in regular contact. And he got his PhD at Duke University a couple years ago. And we were talking about, he was thinking, does he want to go the academic route? Does he want to be a professor? He didn't want to be a teacher at a small school. He wanted to go, if he was going to be a professor, he wanted to be one at a large research PhD granting institution. But he also could see himself as being happy in the private sector. And so we talked about it, and we talked about how if you want to be a professor, you're going to have to be a postdoc multiple times. And there's going to be no guarantee that at the end of that, you're going to get a faculty job just because of the numbers. And if you think you can be happy working in private industry, perfectly happy, then that's probably a better option for you. And he agreed with that. And so now he works at Apple studying computer vision and self-driving cars, and he loves it. It was definitely the right choice for him. And so that was, he's a resounding success. Sometimes there are professors who think that excuse me, the definition of success is becoming just like them, becoming a professor. Don't ever let anybody tell you that. you can be successful. Success means finding something that you find personally fulfilling, and Timur definitely did that. But it's also important to say that not everybody is going to earn a PhD. Not everybody should go on to earn a PhD. In fact, the American Institute of Physics Statistical Research Center estimates that only about 1 in 7 folks who receive a bachelor's degree in physics are going to end up choosing to finish a PhD in physics. Only about 14% of all physics degree holders actually become physics PhDs and become, quote unquote, traditional physicists. So what can you do if you don't have a PhD? What kind of opportunities are there for folks who have a bachelor's degree or possibly a master's degree? Well, one traditional route that people take is maybe your dream is to teach the next generation of young people. Maybe you want to teach physics in high school or be a middle school science teacher. In that case, a physics or an astrophysics bachelor's degree will prepare you well for that. But there are also jobs for you in the private sector. Physics bachelors working in private industry have excellent earning potential, and they tend to work in the same kinds of jobs involving computer programming or engineering as degree holders in those fields do, because you're receiving technical training. You are learning what we like to say are transferable skills as a physics or astrophysics major that makes you a candidate for any sort of technical employment like that. So let me show you another graphic from the American Institute of Physics that shows salary ranges for various bachelor's degree holders. This is between the 25th and 75th percentiles for each one. And notice physics does really quite well. It's pretty high up on the list. So a physics degree really can pay for itself. College is expensive, but you earn skills as a physics or astrophysics major that make you very marketable and give you a good earning potential. And again, that is nothing to sneeze at. One of our students who's a real world example is Guillermo Gutierrez, who graduated in 2018. He majored in astrophysics and in politics and government, and did some internships, including a science policy internship at the American Physical Society. He's not interested in going on to earn a PhD. He today is a data analyst at JDSat Operations and Big Data Sciences. And he recently started, he does want to earn a master's degree in operations research at George Mason University in order to increase his earnings potential. So he's interested in big data. He did a senior project where he was doing a big data project involving politics, essentially, because of his interest in politics and government. And so as a result of that, he parlayed that interest into what is turning out to be a very fulfilling career for him. One more thing I will say is that there's more to being a physicist than acquiring, and an astrophysicist than acquiring technical skills. Everybody needs to be able to communicate. So when you're taking quote unquote distribution courses or core courses, humanities courses, don't look at those as hoops you have to jump through. Look at those as part of your professional training. Look at learning how to write well and to speak well as crucial tools that you're going to need on the job and in the world, because you can have the greatest ideas in the world, but if you're not good at explaining them to other people, then they're not as likely to be implemented. All right, with that, I am going to stop and invite any questions.
Superb. Thank you so much, Professor Harmon. We have, it was a superb session, and we do have some questions coming in, and I'll start reading out these questions for you one by one. So, okay. What is the difference between physics and engineering physics?
Yeah, between physics and engineering physics. So really, engineering, many branches of engineering, so mechanical engineering, electrical engineering, those are really applied physics too. So from the standpoint of engineering physics versus engineering, for those kinds of fields of engineering, there's not so much of a difference. In other words, I would say engineering physics on some level is, well, you're a physicist who is applying your skills to engineering problems. In connection with that, I'll note that Ohio Wesleyan and many other small colleges don't have an engineering program per se, but we have what we call 3-2 programs, where you study for 3 years at the small college, and then you, with a partner institution, go for 2 more years, and then you'll get a physics degree or a chemistry degree or whatnot, depending on your interest, from the small college, and then an engineering degree from the other school. An advantage of that goes back to what I was talking about with learning to communicate. Small colleges are really good at training you to communicate. You take more courses outside your major at small colleges. And an advantage also of majoring in physics and then going on to engineering is that it's a simplification, but in physics, we tend to be much more interested than engineers are. Again, this is a simplification in the whys behind the equations, learning the details of what's behind the equations on a more fundamental level, whereas in engineering, it's often kind of more applied. Here's the equations, how do I use them? With physics training, it gives you a way to think outside the box. You've got a deeper understanding of the engineering problems that you're trying to solve. And so on some level, then being an engineering, engineering physics person, you've got that additional training, more fundamental level that gives you greater flexibility in how you approach problems.
Okay, wonderful. One student wants to know, can we combine our passion in physics and biology? Do you see students doing physics and bio together?
Yeah, we sure do. In fact, we have a freshman this year who's interested in astrobiology. And so what we're doing is he will major in astrophysics, but he will also either major in biology or minor in biology. Absolutely. Here at Ohio Wesleyan, we're certainly, other schools as well, but in small schools, it's often easier to do this. We have a lot of students who do multiple majors, combined majors. And physics and biology can be a good combination. There are many people who call themselves biophysicists. And so absolutely you can combine physics and biology, and it's a good field to get into. There's a lot of demand for biophysicists.
Okay, wonderful. Can you highlight the difference between astronomy and astrophysics?
Yeah, so it really does come to kind of what I claimed there before, that there's really not that big a difference between them. There's no real formal difference between them. So it's informally, sometimes we say that astronomy is the part where you're gathering data through telescopes and doing data analysis. And astrophysics is where you're working more with computer or pencil and paper to develop mathematical, theoretical models of the things that the observers are, the data the observers are getting through their telescopes. But really, it is kind of it's kind of an artificial distinction. And so it doesn't really make any sense to say, there's nobody, let me put it this way, there is nobody who could be said to be an astronomer instead of an astrophysicist, or an astrophysicist instead of an astronomer. They're all astronomer/astrophysicists.
Okay, got it. And it's just that astrophysics sounds better when you talk about it at a cocktail party.
That's right. Yes, it sounds very impressive at a cocktail party. When I go to the doctor, as in a physician, it's kind of funny because I can get, or actually not even that. It's just whoever I meet, I can choose my reaction, so to speak. If I tell somebody that I'm a physicist, I often get like, oh my gosh, oh. And if I say I'm an astronomer, they're like, oh my God, did you see that Hubble Space Telescope photo? If I say I'm an astrophysicist, they might want to run away again. So it depends on the reaction I want.
Okay. Okay, so here's another question. Can a physics major go into the space industry, and I'll include NASA into that, referring to activities which are related to manufacturing components which are required to maybe build satellites or build space shuttles?
Sure. Yes. Absolutely. So there's a couple of routes you can take. So one is straight up be a physics major, and then parlay that into a career in aerospace industry. So we have a graduate from the class of 2012, Zeke Brechtel, who for a number of years was working at SpaceX after getting his astrophysics degree from Ohio Wesleyan. We have a graduate from the class of 2008, Steph Vazacek. She works at Boeing, and her major was physics. The other thing you can do is aerospace engineering. And of course, you can go to a school which offers aerospace engineering, but on the other hand, you can also do a 3-2 program. And so we have a student who is a physics major who loves aerospace and wants to do aerospace engineering. And he's decided to stay here for all 4 years, but he'll go on most likely and get a master's degree, kind of an unofficial 4-2 program in aerospace engineering. And again, the advantage of doing the physics first route and then the engineering route is you learn things at a more fundamental level as a physics major than you typically will as an engineering major. So you kind of get the best of both worlds there.
Okay, I think this is a sort of a question which is a follow-up question about the physics plus bio. Can you tell a substream in physics that can go in perfect rhythm with biology?
A substream in physics. So for example, there are folks that are neurophysicists. So they study neuroscience and physics. And it's possible to take courses in neuroscience and combine them with courses in physics and be well prepared to be a neurophysicist, for example. In general, I would say that one's best option is to combine either a physics major and a biology minor, or a biology major and a physics minor, so that you get the variety of courses that you need in order to be a biophysicist. And if you're really ambitious, major in both, but you have to be a very dedicated person who wants to do a lot of work if you're going to major in both. You can certainly do it, but it takes a lot of dedication.
Okay. And is bio, it's just from my side, maybe is biomechanics a sort of related field? Maybe when people like making artificial limbs or things like that.
Yeah. Yep. That's essentially, you could think of that as being a branch of mechanical engineering, okay, but you're applying it to biological systems.
All right. Okay, so we have another question, which is again on the similar lines. What is a combination of physics and chemistry?
Right. So physical chemists are people that use quantum mechanics in order to study molecular dynamics and reactions and so forth. Certainly, chemists, by their nature of the major, they have to take some physics courses, and chemistry involves taking a quantum mechanics course. And a few years ago, I had a chemistry major who took quantum mechanics with me because she wanted to get the physicist perspective on quantum mechanics. And again, it was, there's a different perspective in that in physics, we tend to be approaching things at a more fundamental level, so that you get kind of an in-depth knowledge of what's behind the subject that you're studying. But certainly there are folks who combine chemistry and physics interests, and that's also a very viable combination to either double major in physics and chemistry or major in one and minor in the other.
Okay. Another student says, I love both physics and math. What kind of research projects can I do at high school to build my profile? Any ideas? And Christine, feel free to plug in for this particular question.
Yeah, I mean, I will say there's various possibilities. If you can manage it, it would be a good idea to see if you can become part of a larger program. So this past summer, I worked with two of our incoming students, so students who had just graduated from high school, in what is called the Our Solar Siblings project, which is run out of Australia. They have a worldwide network of telescopes that they use, among other things, to study variable stars. And the program is open both to undergraduate college students and also to high school students. They do research projects, they're accessible to high school students, which then allows those students to already have a research experience before they begin college. So that's, like I said, it's called Our Solar Siblings. So if you Google search that, you can find out about that and see if you can become involved in that. You would be working with a teacher at your high school. And there are other things like that as well. And I think that sort of thing is ideal because then you're working with college professors along with your high school teacher and getting a really high quality research experience if you can do that.
Got it. Apart from research, what do astrophysics majors do? What kind of jobs do they do?
Yeah, so I was at a dinner with the board of trustees here at Ohio Wesleyan, and I was sitting next to a board member, and he heard that I was an astrophysicist, and he kind of jokingly said, "Oh, so your job is to train other astrophysicists, because that's what astrophysicists do, right? Is they just create astrophysicists." And I was glad he asked me that, because that simply is not the case. You learn transferable skills when you major in astrophysics. You take a lot of physics courses, you take a lot of math courses, you take humanities courses. You learn things that are widely applicable to many kinds of jobs. And so, for example, at American Astronomical Society meetings, the professional meetings for astronomers where they present their research, banks and investment firms actively recruit there. I remember a couple of years ago walking by a booth that was put up by a bank with a big poster that said, "The skills you've learned studying astronomy and astrophysics are just what we're looking for at our bank. And so come and talk to us about career opportunities." So sometimes parents imagine that if my child majors in astronomy or astrophysics, they're not going to have any job prospects. Trust me, that's not the case. Most people that major in astronomy and astrophysics go on to careers that are not actually in astronomy and astrophysics, but that make use of the quantitative reasoning skills they acquired, the critical thinking skills that they acquired. It's a very viable route in terms of career preparation.
Wonderful. Okay, another question here is, can one combine astronomy and chemistry, like astrochemistry?
Yeah, there actually is such a thing. Yeah, you name it, you can pretty much combine it in the sciences. In fact, one thing that is becoming more and more important in today's world and in scientific research are people that are interdisciplinary, that combine skills and knowledge from different fields in the sciences. Astrochemistry is not just a name that you made up a moment ago, it's a real thing. There are astronomers whose professional interest is studying the interstellar medium, the stars and gas and the gas and dust between the stars. And spectroscopy shows us that there are molecules there. There are organic molecules, there's a wide variety of molecules there. And in order to understand that, you need to not only know astrophysics and physics, you need to know chemistry. So somebody who wants to do that is somebody who should have studied chemistry as well. So you certainly can combine those things and use them in your work.
Okay, when I saw that question, I thought that was a made-up word, but I was wrong. Okay. So we have a couple more questions here. Do we need to be good at math to study astrophysics?
Yes, you do. So if your job if your dream job is to be a professional researcher, like you want to get a PhD eventually, then the math should come. Well, I wouldn't say it should come easy to you. I mean, math is hard even for mathematicians. Physics is hard even for physicists. It's supposed to be challenging. That's part of the fun, if you will. But on the other hand, if you're bad at math, or whatever, and sometimes people think they're bad at math and they're not as bad as they think they are. But if you're afraid of math, if doing calculus scares you more than it excites you, it's probably not your best choice of a major. Or at least it could be a viable choice for a major as long as you're not looking to get a PhD, if you're more interested in getting your bachelor's degree and doing something with that.
Got it. How different or difficult is college level physics than high school physics?
Mm-hmm. So I would say on one level, it depends on who taught your high school physics. There's a wide variety in my experience of the rigor of high school courses. So the first year of college physics, you study the same kinds of things that you do in a calculus-based high school physics course. But I will tell you that in our experience here at Ohio Wesleyan, even students who took the advanced placement test or have, like IBs or whatever, if they're trying to use their scores to get physics college credit and they want to major in something else, that's fine. But if they want to major in physics or astrophysics, we generally find the best advice for them is to go ahead and take our freshman physics course, because it's so foundational. And it's not like your time spent in high school physics was a waste of time, because you'll do better. You'll have seen the material before, you'll do better as a result of that. But we do find that it tends to be a step up at the college level compared to the high school level. But having said that, I will say that if you are in a good high school physics course, it's challenging and you are doing well in it, then there's every reason to think that you will do well in a college physics course.
Okay, wonderful. So we are towards the end of the session. And before we close, I would request both Christine and Professor Harmon to share their final word of advice with these young high school students who are some of who might be looking at OU, and I'm sure most of them are looking at physics or astrophysics.
Mm-hmm. So one thing I will say is that here at Ohio Wesleyan, we take a very personal interest in the development of our students. You certainly are not a face in the crowd here. We have a relatively small number of physics and astrophysics majors. And so, several times I said things like, yeah, Timur and I are still in contact with one another. And Rachel and I still publish papers together. I'm not going to say that I remain in close contact with every graduate, but I do with a lot of them. I keep in touch with them. If you want to study astrophysics, I should probably mention that Perkins Observatory here at Ohio Wesleyan is a really great facility. It was by collegerank.net a few years ago, ranked number 15 on their list of the 35 best college observatories. And all the ones that they rated higher were big school observatories. So they were kind of unofficially saying it's the best small school observatory in America. It's a really nice facility. You'll get to use it if you come to Ohio Wesleyan. And we're a very friendly department. And so, if you want to know more, by all means, get in touch with me and I will tell you all about us.
I have added a bunch of links in the Q&A boxes. So if you're all still with us and you want to scroll back up, while I'm talking and click on the links and maybe bookmark them. I've added links to Perkins, to our observatory, and we do have some live Zoom events every now and again, so you might be able to join us for those. I've also posted information in there on our interdisciplinary courses, our majors, and I've also posted a link to a video in there of Dr. Harmon giving his iCubed lecture on do you think you're star material? And that's a really interesting lecture, and I definitely think that you should check it out for a taste of some of his courses and lectures. And I'm also going to paste a link into the box. So if you do want to stay in touch, fill out this form to get on our mailing list. And I just want to leave everybody with a few final words, is that when you apply to Ohio Wesleyan, if you decide you want to do that, you're applying just sort of in general, not necessarily to a major. And sometimes students feel pressure like, oh, I have to have certain math classes and science classes to apply to a certain major. But the good news when you apply to Ohio Wesleyan is that I'm not going to be looking and seeing, oh, does the student have higher level IB biology and higher level IB physics or certain math classes. So as long as you've sort of generally fulfilled science and math requirements and other requirements, you've got some great chances of being admitted to Ohio Wesleyan. And I definitely welcome you to contact me if you want to know more about if you think you are a match. Any other final words that either of you want to leave?
You know, I'll follow up on your comment about they don't necessarily have to have like taken calculus or whatever. And that's to point out that when I started college, I had not taken any calculus whatsoever. All my calculus I learned in college, and I like to think I turned out okay. So that's not a worry as far as that's concerned. If you had calculus and physics, great, that's a plus. But certainly you don't have to already be an expert in calculus to think about doing physics or astrophysics here.
And if any of you have had trouble registering for SAT exams, and if you're worried that you're not going to be able to take some subject tests or even the regular SAT or ACT, that's not going to affect your chances of admission. So please put that out of your mind. We'll just review you in the context of this crazy pandemic year, and you will not be placed at a disadvantage if you can't register for standardized exams.
Wonderful. Thank you so much, Professor Harmon and Christine, for this superb session. And thank you, Ohio Wesleyan University, for supporting us in this, and for, of course, having Professor Harmon present this session. It was a superb experience. We learned a lot. And now that we are towards the end of this whole webinar series, I want to also thank all the participants who joined us for this series and helped us in making this possible. So once again, thank you so much, both of you, for joining us this morning. Have a great day ahead. Yeah.
Thank you so much.
Yes.
Yeah, we hope to stay in touch with everyone.